Namaste and welcome to Apna Gurukul. One little step towards success. We are discussing number system, the first chapter of class 9's NCERT. And so far we have discussed about the definition of rational numbers, irrational numbers, how to plot them on number line. And we have also discussed recurring and terminating decimals. I hope you are very much clear with that. Very quick revision. Recurring decimals are the decimal expansions which end after a few decimal places. Terminating decimal place, recurring which does not end, the recurring decimals which does not end but keep on repeating again and again. Terminating decimals, they end after few decimal expansions, right? So now we raised a question in one of the previous videos, that how can we tell that terminating and recurring decimals are rational numbers. Now we know that rational numbers are the numbers which can be defined, which can be written in the form of p by q, where p and q are integers. So can we write the decimal expansions, the terminating, that's the first case, and then non-terminating recurring decimals into p by q form? Because we know non-terminating and non-recurring are are irrational numbers, so they obviously cannot be written in p by q form. Yeah, because that's how the definition of irrational goes. So let's begin with a very beautiful quotation. Maths is more of self-teaching and less of instructional teaching, because as we know, math is all about more and more practice. As we teach ourselves every time, we tend to link things between in mathematics, and that's how we learn more of mathematics, through self-teaching. So let's begin. Recurring decimals to p by q form, because that's how we define rational numbers. Now before that, there is a one example of terminating, and this one is easier, that's why I have taken only one example. So suppose I have 3.142 142,678, 3.142,678. So what do we have to do? We have to move this decimal place towards the end. So whenever we move the decimal places towards right side, I know you are very much clear with that. So when we have to move that, what do? How many decimal places are there? 2 plus 2 plus 2, 6, right? So we multiply and divide by a number which has 6 zeros. That's all. Okay. So when we divide it with that, 2, 4, and 6, so we get the number. Now when you multiply the numerator, you will get 3142678 divided by 1 and then 6 zeros. So that is the process of converting the terminating decimals into p by q form. As you can see, this is an integer and this is also an integer, and obviously the q is not equal to 0, so it becomes a p by q form. So this one, the terminating decimals, are rational number. We are 100% sure now, right? Now I hope that you know already the reason of this process. Okay, if not, let me quickly explain this. So suppose I have 2.3 and it ends over here, right? So I'm taking a smaller one because it's easier to explain. Now what did we do? How many decimal places are there? We multiplied by that and divided by the same number. So what exactly did we do is, so whenever you multiply 2.3 times 10, we get a natural number, yes or no? Or we can say an integer. We are not left with a decimal number, right? So 2.3 times 10 gives us. So that is why we count the number of decimal places, and that many zeros, if we multiply, we can get an integer in the numerator. Now why do we multiply by 10 in the denominator? Because if we only multiply it in numerator, we are changing the number itself, we are changing the question, but we are not allowed to change the question at any moment of time. That is why whatever operation we do, multiplication or division, we do in numerator, that same thing we have to do in denominator, and that's how we multiply by 10 in the denominator as well. And the same process goes for all the terminating decimal expansion. I hope that makes a lot of sense. Now, the main hero of this particular video is how to convert recurring decimals to p by q form. Now, I have taken 5 different examples, all different kind. Okay, so as you can see, in the first case only one number is repeating. In this case, two numbers are repeating. In the fourth question, three numbers are repeating. Fifth and sixth one are very special. As you can see, after the decimal, one number is not repeating, that is 3. But 262626, that keeps on repeating. It is still a recurring decimal expansion. So how do we convert that? We will take a look at that. In the sixth question, as you can see, 4 and 7 is not repeating. 3 bar, that means 3333, it is repeating again and again. Now, that's the way we represent it. 3 to 6 means the 2 6, if we have a bar above 2 6, that means 2 6 is repeating again and again. 3 is not repeating. That is the representation, and I have shown it here as well. 0.33 means 0.3 bar. 1.2727 means 1.27 bar. So now let's understand how do we make it into a fraction form. I would rather say, instead of p by q, again a fraction form. So now I have 0.3333. Okay, and this keeps on repeating. This dots represent that it keeps on repeating. So what do we do now is we will represent this as x. We will take it as x. Okay, and then what do we do is, now to make it into like to how many places are repeating. Okay, one place is repeating, so that many zeros we multiply. That means 1 and that many zeros we multiply, so we multiply it by 10x. If it was 2 places which are repeating, we multiply by 100x. If it was 3 places which are repeating, we multiply by 100x. Why do we do that? I'll let you know in a while. Okay, as I told, we'll try to discuss almost all the reasons of why do we do things in mathematics. Okay, so 10x, so then we get 3.333, and this keeps on repeating. Okay, so now what is the next step we do? We subtract 10x minus x. Yep, so that gives us 3.33, and this keeps on repeating, minus 0.33333. Okay, so now if it was not repeating, okay, let's suppose if it was not repeating and we had to subtract number 2.45 minus 0.45. So what happens to the places after the decimal? They become 0 0, right? Now this number is continuously repeating, but the same number is repeating, and if you are subtracting by that, what happens to the numbers after the decimal? They become 0, and we are left with 3.0000. At 10x minus x is 9x. I hope you are very much clear with that. Now 9x is in 9 is in multiplication with x. When it goes to the other side, it becomes x equals 3 by 9, and that gives us 3. Once again, we'll simplify 3 times 1 and 3 times 3, so we get 1 by 3. So x equals 1 by 3 is our fraction form. Since 0.3 bar can be represented as 1 by 3, this is a rational number. I hope that makes sense. The process makes sense. Still, the reason is not clear. Why are we multiplying by 10, and in the next question we are multiplying by 100? Okay, so now the reason will become clear. Now we have 1.27 bar. Okay, let's put our line here so that we do not get confused. Now we are taking x equals 1.27 bar. Now what did I tell? How many decimal places are repeating again? 27. So that means I have to multiply by 100x, right? So if I multiply 100 to it, what do I get? 127.272727. This 27 is repeating again and again, right? So what is our objective right now? We are trying to multiply with a number such that after decimal expansion, we get the same numbers. I repeat, we are trying to multiply with a number. We are trying to multiply x with a number so that after the decimal expansion, we get the same number. Over here, we had to get 3333 after decimal expansion, so we multiplied with 10 because that was enough. Over here I have to multiply, because if I multiply by 10, let's take that example also. If I multiply by 10, I will get 12.72727. Now I cannot subtract and cancel out the places after the decimal, yes or no? That is why we tend to look for multiplication such that after the decimal we have the same digits. I repeat, we look for the decimal expansion such that after the decimals we have same expansion. I hope that is clear. Once again, now why do we look for that is that will become very clear in this particular x. 100x minus x we do. Now 127.2727 minus, means this will keep on repeating, minus 1.2727, right? So now we look for this decimal expansion, because when we subtract it, the places after the decimal will give a zero as it gave over here, and we will get a natural number, and that is what we are looking for. I hope that makes sense. The process is making sense now, right? So now it becomes 99x equals 126, x equals 126 by 99, and then can you simplify it further? 6 plus 2 8 plus 1 9, so you can simplify it. We can divide it by 3, so 3 times 4 and 3 times 2, we can 3 times 3 and 3 times 3, we can still divide it by 3, so this becomes 3 times 1 and 3 times 4, and this becomes 11, so we get x equals 14 over 11, or we can also write it in mixed fraction as 1 3 by 11. Right? So I hope that makes a lot of sense to you guys, to my dear student. Yeah. So that is how we now, as you can see, x is this one and x is also 1.277. That means they are equal. So we can now represent 1.27 bar is equals 1 3 by 11. Similarly, if we go for this one, so x equals 0.235 bar. So since there are 3 decimal places which are repeating, we'll must subtract it by 1000x. So 1000x will be 235.235 bar. When we subtract 1000x minus x, now I'm doing a little bit fast because we have already understood it. So 235.235 bar minus 0.235 bar, and then you can subtract it. I'll change the ink so that, yeah, so that becomes 999x equals 235, because the places after the decimal will get cancelled out. So x equals 235 divided by 999. You can further see if we can simplify it. If we cannot simplify, this particular fraction is the answer. Okay, you can further test it out with that. We can just quickly do it. 2 plus 3 is we can test it by 3. So 3 plus 2 is 5 plus 5 10. The numerator is not divisible by 3. The denominator is divisible, but we do always simplify by the number which can divide the numerator and denominator. It is not divisible by 9. It's not divisible by 6. 7 as well, it's not divisible. So that means this is the final simplified form. You can try with 11 also. It's not divisible. 11 times 2 is 12, and then we get a carry over 15. So this is not divisible further. So that's how this particular fraction can be written as 235 divided by 999. I hope that makes sense. Now comes the 5th and 6th question, which are a little bit different and very important. Not very important, but yes, it's a lot of, it's more of interesting rather than important, because I have already told we are not focusing on marks here. Okay, so let's understand this particular. So 0.326 bar. Okay, let's put a bus scale. X equals 0.326 bar. So now you might have observed we are trying to keep, I'll repeat, On the right side of the that after the decimal expansion, we are trying to keep the numbers which are repeating. That means over here we have to keep somehow 26 bar, only 26 bar after the decimal expansion. What are the possibilities? Okay, so if I multiply by 10x, what happens? You can pause the video and think about this process for a while and try to solve it, and then after I explain, you can match your answer, put a tick mark and feel proud about that, because this is a little different question. If you have tried, you can listen now. How do we do that? So 10x equals, now why do I multiply by 10x? Because we have observed that on towards the, like after the decimal expansion, we are trying to keep only the numbers which are repeating. So if I multiply by 10x, I get 3.2626, right? 2626 keep on repeating. Yes or no? Now, after that, what else can I multiply? If I directly subtract 10 minus x, I have 326 over here in the after the decimal, and I have 2626 repeating here. So I'm not getting zero after the decimals, and I'm not getting an integer, right? I'm getting a decimal back again. So what's the process? Okay. So if I now multiply it by 1000x, so what do I get? 326.262626. And since this is not ending at all, we can keep it at take any amount of numbers. They will cancel out until it is repeating. Yes or no? So now what do we do? 1000x minus 10x equals 326.2626. I'll write 26 bar to make it easy. Minus 3.26 bar. So 2.26 bar and 26 bar, they make it 0. So we are not bothered about that right now. So 326 minus 3 gives us 326 minus 3 gives us 323. Did I say 323? 326 minus 3 gives us 323. 1000 minus 10 is 990x. So x will be 323 divided by 990. I hope this was pretty much interesting and you had to use your brain a lot. I'm enjoying this discussion a lot. I hope you are enjoying this along with me as well. Okay, let's go for the final question of this discussion. 0.473 bars. So this was the fifth question. And let's move on to sixth question. So we have 0.473 bar. So 0.473 bar. Yeah. So this is nothing but x. So what do we multiply with? We have to get 3 bars, so we can multiply it by 100x equals 47.333333, and then we can multiply it by 1000x. I know you have solved this by pausing the video. I need not say, whenever you get a question, just pause the video, try it yourself first before we start the discussion. I'll be teaching, we will be discussing a lot of problem solving techniques as well, how to understand the problem, how to deal the problems in the mathematics as well as in real life as well. The same things applies, but we will try to discuss in separate videos. For now, let's focus on the problem solving of such kind. So we get 473.33333, and this continues. So now 1000x minus 100x, when we subtract it, we get 473 minus 47, because decimal, after the decimal we have same number, so they make it 0. 13 minus 7 is 6. We have taken one carryover, so this becomes 6. 6 minus 4 is 2, and then we have 4, so 426. So 1000 minus 100 gives us 900x equals 426. X equals 426 by 900. And as you can see, 426 can be divided by 3, and this also can be divided by 3. So we get 3 1s are, 3 4s are, 3 2s are, and 3 3s are 9, and 0 0. Can it still be divided? No. So it can be divided by 2. I didn't see that. I'm sorry. So 2 7s are and 2 1s are, and to 150. So the value of x equals 71 by 150. So that means 0.473 bar can be represented as 71 by 150, and that's the answer we have got. So I hope that discussion made sense to you. Yeah. So now the next topic which we have under this is, can we find irrational numbers between irrationals? Between rationals, and then the next topic will be, can we find irrational between irrational numbers? Yeah, so this is very interesting and very easy topic, I would rather say. So what do we do is, whenever we have rational numbers, obviously we can write that in the form of p by q. So we have p by q form given, 1 by 2 7 and 2 by 7. We have to find irrationals between them. So what do we do is, we find their decimal expansion. So as you can see, we have a recurring decimal expansion, 0.14257 and 0.285714. So these are only the repeating terms as well. Okay, so this is repeating. We have to find irrational numbers between them. So I would just, you can just pause the video and try to do it yourself. I hope you have done it. Let's try to understand 0.142857. So how do we construct an irrational number? Okay, so I'll tell you a very beautiful trick. Okay, if I write 0.15, yeah, so it is already greater than 14, that means, and 28, that means it is between them, and we are finding irrational between them. Okay, now make any kind of pattern, 0 1 0 0 1 0 0 0 1 0 0 0 0 1, and so on and so forth. This pattern is never ending, and this pattern is not repeating as well. Okay, there is some repetition, but that repetition is not the same number repeating. I hope you understand that. Yeah, and let's try to make one more. So 0 point, I'll make 2 1. As you can see, 2 1 is greater than 14 and less than 28. 2 1, and then I can write 5 6 7 6 5, again 6 7 8 7, and this particular continuation. There is no continuation, right? There is no repetition. I'm just making a pattern out of the numbers. So how many such creative patterns you can make with numbers? Infinitely many. So there are infinitely many possibilities of irrationals between rationals. Yeah, now the question arises, writing irrationals between irrationals. Once again, the same procedure, 0.01. As you can see, the irrationals itself, you can see a pattern over here, right? So how can you find it? Of course, if you write 0.1 and then write one pattern, 1 1 1 0 1 1 1 0 1 1 1 1 and 0, and then continue, right? Again, it is not terminating, nor it is repeating. So non-terminating and non-recurring. Yeah, so that makes it irrationals between irrationals. How many such patterns can you make? Infinitely many. So we can find infinitely many irrationals between any two irrationals. We can find infinitely many rationals between irrationals. Yeah, so that is how you can plot it on the number line as well. We have already discussed in the second video of this particular series, how can we divide the number line between number line. We can magnify the number line. So that process is called as successive magnification. That's a very easy process. We just keep dividing the number line, and that's how we can plot any number on the number line. Okay, we already had a lot of discussion. Now, there's a very important, not an important question, but an interesting one rather. Yeah, I would rather use interesting word rather than that. Okay, so now we have 0.999 equals 1. So how do we represent that? Yeah, so that might be a question. So it is, when you try to find it, 0.9, as you can see, let's find it out with the process we have discussed. So that means 0.9 bar it is. That is equals x. So we just need to find 10x equals 9.9 bar. So when you subtract 10x minus x, you get 9 minus 0 is 9. So 9x equals 9. x equals 9 by 9, which is 1. Now, what's the meaning of that? X, we are getting it as 1. That means 0.99999 equals 1. Why? And how can we verify that? My dear friend, try to understand. It's not saying that 0.9 equals 1. We are not approximating 0.9 equals 1. We are saying 0.9999. It's continuously going on till forever. And that is why we are getting it as 1. It's because the process which we are using is, this process is neglecting the infinity. This process is taking infinity as a number, what the process which we have learned. But actually, infinity is not a number, and that is why your teachers might at times in the school, they would be asking you to not use infinity as a number, okay? Because infinity is just a concept. The infinity just says that there is a concept in mathematics which says that the numbers does not end. That concept is infinity. Okay, infinity is not a number, but over here in this process we are taking infinity as a number, and that is why we have a little bit of approximation. So there is a little bit of approximation in this process, and that is why 0.999999999, which keeps on going, we get it as 1. Although that approximation is negligible, it is not visible in all the other examples which we have done, but it is visible in 0.999 equals, means this, so goes on repeating, equals 1. Okay, so you can also try to verify whatever we have done. So whatever we have performed, like 1.3, if you try to divide 3 by 1, so 0 point and then 10, so 3 threes are 9, and then we once again get 1 0 3, and this keeps on repeating, as you can see, right? So we have verified it. So we are not saying that it is inaccurate, but yes, there is a little bit of approximation involved, and that is what this result says, 0.999 equals 1. Okay, that's all it says. Okay, so I hope you enjoyed this process. I hoped you learned this process. Thank you so much for your patience hearing. You were listening to Apna Gurukul, one little step towards our success in mathematics. I hope you loved this video. I hope you learned this concept. If you have doubt, just let me know in the comment section, or stay tuned for 12 p.m. IST Sunday, where we meet live, where we will be meeting live every Sunday and have a Q&A session, and obviously a lot of masti and enjoyment altogether. Thank you so much for your patience hearing. See you in the next video. Until then, keep smiling. Jai Hind.